So remember from last video, we solved a problem using something called the power rule. So today we are going to prove this power rule, okay? So restating the power rule, let's just write it right here. Okay, so the power rule states that if we have an f of x equaling to a single term, which let's say a times x to the nth power, okay? Then f prime of x, which is the derivative of f of x, is equal to an times x to the n minus 1 power. So to prove the power rule, we again need to use the definition of derivatives. So let me just write the two definition of derivatives out. So the first one is that f prime of x is equal to limit as h approaches 0 of f of x plus h minus f of x over h. And the second definition of derivative is that f prime of a is equal to limit as x approaches a f of x minus f of a over x minus a. Now, for this problem, we are going to prove it with the first definition of derivatives, okay? So getting back to our power rule, so we know that f of x equals a times x to the n power. And so by the definition of derivatives, we have x prime of x is equal to limit as h approaches 0 of a times x plus h to the n powered, because from our expression, right? And then minus a times x to the nth powered over h, okay? So we can simplify this expression a bit, just factoring out the a. Okay, let's just factoring out the a, leaving us x plus h to the n powered minus x to the n powered over h. Now, remember from junior high, we know that we can factor certain equations with certain formulas. So here's one that we need to utilize, which is a to the n powered minus b to the n powered is equal to a minus b times a to the n minus 1 power plus a to the n minus 2 power times b plus blah 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 plus a times b to the n minus 2 power plus b to the n minus 1 powered. So for our proof, we are going to use this formula, okay? So let's just write it right here, and using this formula, let's just kind of expand the limit a bit. So bear with me, this is going to be a little bit long, okay? So again, a is outside here. Now using this formula, we get x plus h minus x, okay, times x plus h to the n minus 1 powered plus x plus h to the n minus 2 powered times x plus blah 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 plus x plus h times x to the n minus 2 powered plus x to the n minus 1 powered. Okay, so don't remember the h on the denominator. Just a little bit long. Bear with me, please. Now, notice that we can basically cancel out the x because it's x minus x. So we're left with the h denominator. And then we can cancel out the h with the h on the denominator. So what we're left with is, we get an 8 on the outside. Okay, x plus h the n minus 1 powered plus um, x plus h to the n minus 2 powered times x plus blah 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 plus x plus h times x to the n minus 2 power. Finally, x to the n minus 1 powered. Okay. So now remember that h is approaching 0. So what that means is that basically we can ignore h. Why? Because h is equal to 0. So it's basically x, right? So we can simplify this into one single expression. Okay, so let's write it out. Again, we have a out the outside, and here we have x to the n minus 1 powered plus x to the n minus 2 powered times x plus blah 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 plus x times x to the n minus 2 powered plus x to the n minus 1 powered. Okay, now notice that every single term is actually equal to x to the n minus 1 powered. Look at this term is equal to x to the n minus 1 powered. This term is equal to x to the n minus 1 powered. And basically every single term is equal to x to the n minus 1 powered. So if we want to factorize this equation, the only thing we need to know now is how many x to the n minus 1 powered there are. So let's just start with the first term, x to the n minus 1 powered. The second term of this is x to the n minus 2 powered. All the way to this is essentially here. So this is essentially x to the 0 power. So what this is telling us is that there are 0 to n minus 1, x to the n minus 1 powered. So how much numbers are there in 0 to n minus 1? We know that there are n numbers, right? So now we can finally simplify this to a times n times x to the n minus 1 powered, because we have n x to the n minus 1 powered numbers. So now this is the answer to our proof. Now notice that this expression is exactly the same with this expression, which is the power rule. Thus, we have proven the power rule.